So it's possible to have, you can get a different derivation with the same parse tree. For example, say, as in grammar G4, and you had the variable expr, and you could replace that with the terminal A, let's say. So imagine in your parse tree, you have two instances of expr in your tree, here and here. And so this is your left one and your right one. Now, you could, at the next step, replace, substitute expr for A by doing the left one first. Or you could do the right one first. Okay? Now, it's not going to change the structure of the parse tree, right? Because the next step you might go A, and then step after that A. Or you might go A, and then A. But the structure of the parse tree doesn't change, right? But the derivation, you derived, you did that one before you did that one, or you did that one before you did that one. So the two derivations are different. So ambiguity doesn't, that's not ambiguity. Just because the derivations are different by changing the order in which you're substituting the rules, the order that you apply the substitution rules. Okay, so ambiguity, you need to be strict about it. Ambiguity occurs when the parse trees have a different structure. Okay, they have different parse trees and hence different meanings, and that's what ambiguity is. So there's a new convention that you can use, and it's called leftmost derivation. You can probably guess what its meaning is. You have a convention that you scan. You look across the string. That'll be a mix of terminals and variables as it exists at that moment, and each time you're substituting, you're applying a substitution rule to change one of the variables into whatever's on the right hand side of the substitution rule. Okay, so the leftmost derivation, to get rid of this different derivations, depending on the order that you apply the substitution rule. Like you do the left one and then the right one, or the right one and the left one. To get rid of that and concentrate only on the structure, you can have a convention of what's called leftmost derivation. And what that means is you look at your string as it currently exists, and you look for from the left hand side, you look for the first variable, not terminal, variable. You look for the first variable, and then you substitute that variable with you use a substitution rule you'll rewrite that variable. Okay, and you just work from left to right. So that's leftmost derivation. Now, if doing that, you still get ambiguity. In other words, you still get two parse trees that are different for the same string. Well, then you have ambiguity. Okay, but by doing it leftmost, then there's no. Well, it's not. You just don't do the right hand one before the left hand one. You just go from left to right. Rewriting each time your leftmost variable in your string. Okay, so that's leftmost derivation. Right, now if you go back to definition on page 104 of your text, definition 2.2, that was an example of leftmost derivation. Right? Now we can use this concept even if you use leftmost derivation, you can still get the same string with two different parse trees, and that's that's ambiguity. So we can put that now in the form of a formal definition. Okay, so it'd be definition 2.7, chapter 2. This is the seventh thing in the chapter. This is do not interpret this 7 here as the seventh definition. Okay, don't be fooled. It's just the seventh thing in the chapter that he's labelled with that number. Okay? So 2.6, maybe it's a figure, it might be a theorem, something else. Doesn't so this does not mean it's the seventh definition. Some authors do that, but it's an absolute pain, because when you go referring back to find it, when it's referred to later in the text, it's all mixed up with numbers of theorems and numbers of definitions and numbers of examples, and so the numerical ordering is all mixed up, and it's a pain to find what you're looking for. Whereas with global ordering, it's much easier to find, and Sipser does that. Many other authors don't, which is annoying. Okay, all right. So we can now define formally what ambiguity is. You say that a string W is derived ambiguously if that string has 2 or more different leftmost derivations. So in other words, despite using leftmost derivation, if you still get a string that has 2 or more different parse trees, then you have ambiguity. Okay, so by using leftmost derivations, you get rid of the problem of you might have the same parse tree, but different order of deriving the string. Like you might be substituting EXPR for A, the right-hand example first, or the left. So to get rid of those differences by using leftmost derivation. And if, despite doing this, you still get the same string with 2 different parse trees, then you have ambiguity. Right? So that would be an ambiguous derivation. Alright. Now, a grammar itself is said to be ambiguous if it can generate at least one string ambiguously. Okay? So you can label a grammar as being ambiguous if it